In this video, we're going to look at quadratic equations which have complex solutions. So if you're brand new to quadratic equations and you don't have any experience of working with them, this might not be the ideal starting point. This is not quite entry-level material for quadratic equations. The ideal audience for this video will have at least a small amount of experience working with quadratic equations, but if you are brand new to them, follow along anyway. We're going to look at a bit of an overview of quadratic equations, and we're going to look at some of the key points that all students working with quadratic equations need to keep in mind. So you should still, if you are new to this, be able to extract some important information from this video. If you are experienced with quadratic equations, then the focus for you here will be more on the fact that we're working with complex solutions for quadratic equations, which is a kind of special category, I guess, of quadratic equations. But let's start by going back to basics, picking up some of the fundamentals. So what is a quadratic equation? Quadratic equation is in the form ax squared plus bx plus c equals 0. This is the general or generic form. And there's a few important things about that general form that we need to keep in mind. So the first is that the a, b, and c values in reality are going to be numbers, are going to be real numbers, not necessarily whole numbers, usually whole numbers, but not necessarily. Most of the problems you work, they will be whole numbers, but they're definitely real numbers. And that's important for what we're going to look at later on. In this example here, the a value is 1. The a value is the coefficient of the x squared term. The b value is the coefficient of the x term, which here is -8. And then the c value is the number tagged on the end. In this case, it's 15. So in an actual quadratic equation, it's not just going to say a, b, and c. It's going to have actual numbers. So we are allowed to lose this term and this term. In other words, the b value can be 0 and or the c value can be 0. It's okay to lose both of those at the same time as long as you retain the x squared term. It's the x squared term that defines a quadratic equation as a quadratic equation. Every quadratic equation has got an x squared term, but it can't have any power higher than an x squared. So that's really the thing to focus on. This is the thing that makes it a quadratic equation. That means that the a value is not allowed to be 0. It can be any other number. If it is 0, then it's going to knock out that x squared term and it's no longer a quadratic equation. For example, if we take away the x squared here, what we're left with is now a linear equation. So it's no longer even defined as being a quadratic equation. So that's a few considerations to keep in mind about the sort of general form of a quadratic equation. We want to focus in now on the solutions to quadratic equations. With quadratic equations, you can have either two solutions or one solution, or in fact, you can have no solutions in the real numbers, but those no solutions in the real numbers might have or will have complex solutions. That's what we want to focus on in this video. Complex solutions doesn't mean complex in the sense of difficult. It means complex in the sense of complex numbers. Complex numbers being a particular type of number. They basically lie on the other side of the fence to real numbers. So you've got real numbers here. Real numbers are all numbers that you're familiar with. Complex numbers are different. We'll look at those when we get to these problems later on. So let's say that we are starting off here with this general quadratic equation. If we do some algebra on that, in particular using the complete in the square technique, we can turn this form here into this rearranged form. So that's probably like 10 lines of algebra, which I'm going to skip just to save a bit of time. But let's imagine you've done all this algebra and you can end up by doing some clever manipulation in this form here. This form here then basically is providing a formula. It's called the quadratic formula. It's quite often on formula sheets. It's a really important formula for quadratic equations. But basically what it's doing is giving us the solutions, because the solutions to these equations are the x values that satisfy the equation. X is a variable here. So this form here says, hey, just take your a, b, and c values from your equation, a, b, and c, plug them in here, do a little bit of numeracy. Usually there's like 2 or 3 lines of numeracy, and that is then going to give you the solution or solutions to the quadratic equation. So this is really convenient because if you learn this formula, it means you don't have to do any algebra to solve these equations. You just plug in the numbers. So that's quite often how teachers will introduce quadratic equations and the quadratic formula, making it more of a numerical thing than an algebraic thing. But just bear in mind that the algebra is being done for you. The algebra is actually quite tricky to get from here to here, but that's been done for you. So if you want to solve this equation, all you have to do is plug in the a, b, and the c values, which is really handy and helpful. What we want to do though is focus in on what's often called the nature of the solutions. The solutions, by the way, are sometimes called the roots of the equation. So roots, solutions are kind of interchangeable terms, and you'll see both. I want to focus in on this part here, the part under the square root, and it's really important because things that happen under square roots give us a lot of insight into what's going on in the scenario that we're talking about. And that's in particular because basically you cannot square root negative numbers. So if you end up with a negative number in the red part here, then that is a special consideration. That's actually the consideration, the scenario we're focusing on in this class here. So there's three scenarios with this b squared minus 4ac. Let's look at them quickly in turn. If that comes out to be 0, so let's imagine the red part is 0, well the square root of 0 is 0. That's also going to knock out the plus and the minus here, so this whole bit here falls away and you're just left with x equals minus b divided by 2a. That means that you're no longer getting two solutions. So that means that if the b squared minus 4ac comes out to be 0 after you've done the calculation, this is implying that you only get one solution for the overall original quadratic equation. By the way, the plus and the minus is in the formula because of the square root. Remember that if you square root any number, you get not only the positive solution, but also the negative. For example, the square root of 16, we think of as being 4. It is 4, but it's also minus 4, because if you square 4, you get 16. If you square negative 4 properly, you also get 16. So every number that you're square rooting actually has two square roots. That's why that is in the formula, and it's really important because when you do work through this formula, you use the plus and you also use the minus separately, and that gives you the two solutions in that particular scenario. And that's a scenario where the b squared minus 4ac, it comes out to be greater than 0. So some number greater than 0, that means that you're going to square root this number, you're going to run through this one time with the plus, another time with the negative, giving you two separate solutions. So that gives you two solutions. So I'm going through that quite quickly because we're not really focused on these two scenarios. We want to focus on the third scenario in this class. And the third scenario is where b squared minus 4ac comes out to be less than 0. So if you've already got some experience with quadratic equations, then you will be familiar with these first two scenarios. This video is really for students like that who have got that experience. That's why we're now going to look at the more vague, the less common scenario where the b squared minus 4ac comes out to be negative. If that does come out to be negative, so imagine in the red part, under the square root to be some negative number, then we know that in the real numbers you cannot square root a negative. If you take a negative number and try and square root it, put it in your calculator, it'll just return an error message, or yeah, this doesn't work. So you can't square root a negative in the real numbers. So when this is less than 0, that implies in the real numbers that we're going to get 0 solutions. So you can see the importance of this b squared minus 4ac. In fact, it's so important it's got its own name. It's called the discriminant. If you're familiar with quadratic equations, you will definitely have seen that term before. It's called the discriminant because it helps discriminate between these three different scenarios. So just by working out your discriminant value and seeing whether it's 0, some positive number, or some negative number, that will tell you whether the original equation has got 0, 1, or 2 solutions. So it's a really helpful little tool. Importantly though, and please understand this point, it doesn't give you the solutions. That is a huge challenge for students to understand, that this only predicts how many solutions you're going to get. It doesn't actually tell you the solutions, but that gets muddled quite often. If you use this whole formula, that will find the solutions. If you use the discriminant part, that will not find the solutions, but it will tell you how many solutions. It's a subtle difference. It is confusing, I know, but by experience, you'll learn to distinguish between those two different things. Anyway, that's the theory. Let's move on and look at our examples. So the first example here, let's start by identifying the a, b, and the c value. So the a value is 1, so there's a 1 in here. The b value is -8, and the c value is 15. What I want to do first of all, I should just say it's good practice to write these down, by the way. What I want to do first of all is just work out the b squared minus 4ac, the discriminant, and see what we get for that. So the b value is -8. We need to square that. So remember to put that in a bracket because that has to be all squared. So it's -8 all squared minus 4 times the a value, which is 1. I'm just going to use a little bracket to multiply these, times the c value, which is 15. like this. So minus 8 all squared, and the reason for the bracket is because minus 8 all squared is minus 8 times minus 8, which is positive 64. If you don't put in the bracket, minus 8 with a squared on the 8 would be negative 64, but it should have a bracket. So this should always be positive. So 64 minus 4 times 1 times 15, which is 60, so that comes out to be 4. The important thing with the discriminant is not the value, it's just whether the value is positive, negative, or 0. So this is positive 4, which is this scenario here, greater than 0. So the discriminant predicts that our quadratic equation should have 2 solutions. So this is greater than 0, so therefore we've got 2 solutions. How we go about finding those solutions? Well, there's a few different methods for actually solving quadratic equations. But, well, actually, let's just quickly do it. We could just plug the numbers into the quadratic formula. In fact, let's do that. Let's just use the whole formula. So the whole formula says x equals minus b. The b value is minus 8, so be careful with that, because that's a double negative. That's minus 8, which is going to be plus 8. Then we've got plus or minus, just copying the formula. The square root of the b squared minus 4ac, the bit under the square root in red, which we've worked out to be 4, so that's going to be the square root of 4, divided by 2a. The a value was 1, it's quite often 1. 2 times 1 is 2, like that. Quite easy to take this forward. That's going to be 8 plus or minus the square root of 4, which is 2 divided by 2. Different ways you can finish this off. I'm just going to go ahead and divide these by 2. 8 divided by 2 is 4. Plus or minus 2 divided by 2 is 1, like this. What we do at this point then is split off one solution, taking into account the plus. 4 plus 1 is 5. And then one solution with the negative, 4 minus 1 is 3. So we get our 2 solutions, 5 and 3. So again, just a quick emphasis on this point. The discriminant gives you a number which is either positive, negative, or 0, but that is not a solution to your equation. That number 4 will not satisfy this equation. This is just a number which happens to be greater than 0, positive, which tells you there's going to be 2 solutions. These are the solutions. These are the numbers that satisfy the equation. If you plug these numbers in separately, one at a time, they will satisfy that equation. Now, in this video, we want to focus on complex roots, non-real number roots or solutions. You'll notice that these are not complex, these are actual real numbers. I just wanted to emphasize by this example the process, and in particular that point about the discriminant, predicting the solution, number of solutions, and then finding the actual solutions. Let's move on and consider the cases where we're going to get complex solutions. Let's start again by identifying our a, b, and c values. I'll just put these up here, I think, just to make some space. So the a value here is 1, the b value is negative 4, and the c value is 6. So we're just going to do a similar exercise to what we did here. It's just that we're hoping that we're going to get some solutions that are slightly different in form to these ones here. So working our b squared minus 4ac, first of all, our predictor, our discriminant. So b squared minus 4 squared minus 4 all squared is 16. I'm just going to go through this quite quickly. Minus 4 times 1 times 6, well, that's 24. So this comes out to be negative 8. Because this comes out to be negative 8, our discriminant is now in this scenario, which predicts that there's going to be 0 solutions for this equation. It's saying this quadratic equation has got no solutions. It doesn't matter how many x values you try, there's no combination that will make that equal to 0. 0 solutions, no solutions in the real numbers, but there might be complex solutions, which is what we want to focus on here. So let's just work it up and see what happens. So the equation, or formula I should call it, the quadratic formula, again, just taking our numbers and plugging them in. So minus b is minus 4, so it's minus 4. It's quite often the case that problems have a negative b value, and it's quite often worked into the problem to try and catch students out. Because of the minus b, you have to remember then it's going to be a double negative. So minus 4 is plus 4, plus or minus square root of b squared minus 4ac, the part in red, which we've worked out to be minus 8, like this, and then all of that divided by 2 times a. The a value here again is 1, so 2 times 1 is 2. So the difference here is that the part under the square root is negative, whereas here it was positive. So we can't square root a negative number, so we can't take this one forward in the same way we took this one forward. What we have to do instead is slightly different. And what we're going to do is a little bit of surd work. So when you're working with surds, remember that if you take a number, say, for example, the square root of 32, surds, or radicals you might call them, allow us to break this down into, for example, root 16, root 2. In other words, any two numbers that times together, multiply together to make 32, can be used to make this kind of product. The square root of 16 is 4, so that simplifies to 4 root 2. We're going to do a similar thing in the scenario with quadratic equations where we've got a negative discriminant, a negative number under the square root, and we're going to choose to break this down so that one of the numbers is root minus 1, okay? And that's really important. You want to make one of them a root minus 1, all of this divided by 2. Now, if we take this forward, the square root of 8, by doing a similar thing here, comes out to be 2 root 2. So we could simplify this here to 4 plus or minus 2 root 2. I'm just going to leave the square root of minus 1 for a moment, all of this over 2. And this is a really important point. This might be new to you, it might not be new to you, but basically we call this special number here, the square root of minus 1, we call this the imaginary unit, and we label it with an I. So this is taking us into the realm of numbers which are no longer in the real numbers. The real numbers are all of the numbers that appear on the number line. So if you imagine 0 being here, and then negatives to the left and positives to the right, and all possible numbers are in there, whole numbers, fractions, decimals, rational, irrational, the number pi, the number e, any number you can think of, they're all real numbers. But you will not find on that number line these numbers, which are complex numbers. In fact, they go up and down the way. And that's a whole other topic in itself. We don't need to go too far into that in this video, but I do want to just emphasize this guy here, which is called the imaginary unit. This is the equivalent of the number 1 in the real numbers. The number 1 is the unit that we use to build all real numbers. In the imaginary world, which are also called complex numbers, we use I as the imaginary unit as a building block for all numbers. So what we're going to do here is replace the square root of minus 1 with I. So this becomes 2 root 2I like this. And just by making this little replacement, let me actually emphasize that in red. By making this little replacement, we're not just giving up at this point. If we were only working with the real numbers, at this point we basically have to give up and we say, okay, well, I can't do this. I can't square root a negative. I'm done. Game over. But just by making this definition, we can now form these complex solutions to quadratic equations. This one will simplify just by, well, let me just maybe squeeze it in on the end here, because we can divide everything here by 2. So 4 divided by 2 is 2, and then we get plus or minus 2 root 2 divided by 2 is just root 2 root 2i. So this here, 2 plus or minus root 2i, those are the two solutions, complex solutions for that quadratic equation. So the first one would be 2 plus root 2i, and the second one would be 2 minus root 2i. So all we've done there is use the same method we did here, but when we got to the point where with the real numbers we'd be stuck, we just substituted in this I, this imaginary unit, and that allows us to form these complex solutions. Let's just quickly go through this other example here. In fact, let's not bother about using the discriminant this time. Let's just go straight to solving the equation. So we're going to get x equals, just plug in the numbers into the formula. So our b value here is minus 8. I'm going to be a little bit lazy here. I know I said earlier it's good practice to write these down, but just to save a little time, I'm not going to bother. So the b value here is minus 8. Minus minus 8 minus b minus minus 8 is going to be plus 8. Plus or minus the square root of b squared, so minus 8 squared, all squared is 64, minus 4 times a times c. Well, a is 1, 4 times 1 is 4, times c, 4 times 21 is 84. All of that divided by 2 times a is 1, so 2 times 1 is 2, like that. So just taking this one forward in the same way we did up here, we're going to get x equals 8 plus or minus 64 minus 84 is negative 20, not 20, divided by 2. And then again, we just do what we did up here. So we can make this 8 plus or minus the square root of 20 times the square root of negative 1, divide all of that by 2. And then we're basically just simplifying and replacing the root minus 1 with the imaginary unit I. So we get x equals 8 plus or minus root 20 I over 2. Could leave it like that. Can probably take this one a little further. Let me just quickly demonstrate why. Root 20, we can use radicals or surds to break down as root 4, root 5. But the square root of 4 obviously is 2. So that becomes 2 root 5. So this here is going to become 8 divided by 2, which is 4. Plus or minus root 20, which is 2 root 5 divided by 2. 2 root 5 divided by 2 is just root 5, so it's going to become root 5i. So again, this one, we were not able to solve it with real number solutions, but we have been able to solve it with complex solutions, just again by introducing the imaginary unit to represent the square root of minus 1. Now, it might seem, if you're new to working with complex solutions or complex roots and imaginary units, it might seem a little bit make-believe, like we're just making up this thing, and we kind of are in a sense, but it allows us at least to define solutions which, constricting ourselves, restricting ourselves to the real numbers, we would have to stop at this point rather than carrying on. So if this is new to you, I can understand that you might think, hey, that's just make-believe. It is kind of make-believe, but at least it allows us to define these solutions. So the solutions here for this equation are x equals 4 plus root 5i and 4 minus root 5i. So it can be confusing when you start to see complex solutions for quadratic equations. When you first start quadratic equations, most of the examples that you work with are going to pop out to give you one solution or two solutions. Further down the line, your teacher will introduce this third, more sinister scenario where the discriminant is negative and you're going to get 0 real solutions. And your teacher might just stop there and say, hey, if that happens, there's just no solutions. And that generally is what happens for maybe like a year or a couple of years. And then your teacher comes back to it and says, hey, that thing that had no solutions, let's make up this I thing and say that there are no solutions in the real numbers, but there are complex solutions. So anyway, I hope that makes sense. If you've got any questions or comments, please leave them in the box below.